regarding the action of transistor, like if it is NPN transistor what will happen and PNP transistor what will happen. We have seen that, and we have also studied that if base is common for emitter and collector, it is called as common base configuration. If emitter is common with the base as well as collector, then it called as the common emitter configuration. If collector is common for base as well as emitter, then it is called as common collector configuration. So most probably we are using NPN transistor with emitter, or you can say common emitter configuration. So we are using NPN transistor with common emitter configuration. So today we will discuss regarding the characteristic of NPN transistor in common emitter configuration. So in your syllabus, whatever we are studying, whatever thing we are studying, whatever the application of the transistor we are studying, all for the common emitter transistor. So let us first try to draw the diagram, or you can say circuit diagram for the common emitter configuration, so that we can draw the characteristic. So let us try to draw the diagram. So we have to take NPN transistor. If I draw the NPN transistor, let me draw the symbol. NPN transistor means here this is N and this is P and this is N, I can say. So, and current always flow from positive to negative, hence I am marking this as an arrow mark. This as an arrow mark. Then this becomes an emitter terminal, and this is base, and this is the collector terminal. I am writing this N inside the circle so that identify. So here this is what the NPN transistor with emitter, collector and base. Now, as we know, this part, base emitter junction, is always in the forward bias. In previous lectures also we have discussed that base emitter junction, or you can say emitter base junction, is always in the forward bias condition. So let us take it is in the forward bias condition means we have to connect this P in a forward bias condition means P stands for P-type semiconductor, where holes are the majority charge carriers, means positive charges are there. Hence, P must be connected with the positive of the battery, and N must be connected with the negative of the battery. So this is what the forward bias condition. And now this is collector emitter junction must be reverse bias condition. Reverse bias condition means this is what the N side or N type of the semiconductor, where electrons are the majority charge carriers. To make this in the reverse bias condition, this must be connected with the positive terminal, and this emitter being the negative, it is connected with the negative terminal. So this is how we can connect. So I'll make the size of battery larger here. So this is what the battery is. So you can say this is in a reverse bias condition and this is in forward bias condition. Now here we have to measure the current flow here. So we have to connect emitter. We have to connect emitter here. That emitter gives a current in microampere. and the most important thing is direction of current. If you draw the circuit, you have to show the direction of the current. So direction of the current IB is in this direction, that is IB, from positive to negative simple, and from the emitter it is positive to negative, hence it is IE, and here also positive to negative, this becomes IC, and here also we have to measure a current, so I am placing emitter which is in milliammeter. Here current is very small, so we are connecting the microampere or microammeter. Here bit current is larger, so we have connected the milliampere, and we have to measure the voltage across this junction as well as voltage across collector and emitter junction. So we have to put a voltmeter here, which measures the voltage. I am just writing voltage value, which measures the voltage V emitter base junction. This voltage gives voltage across emitter base junction, or you can say base emitter junction, and whatever the voltage you measure here, that gives voltage across collector emitter junction. So this is what the circuit diagram is. Very simple. Here VEB means voltage across the base and emitter junction, and here voltage means collector and emitter junction. So to avoid the damage of this transistor, we have to fix an resistor at input. This is called as RB, and here we have to connect a resistor to avoid the damage, that is R current, or you can say RL, load resistance, you can say. Now this is positive and this is negative, and this is positive and this is negative. This battery supplies the current to the base side, hence voltage or EMF produced by this battery is given by VBB, and this is connected to the collector side, hence it provides the voltage, or you can say EMF, of V, C and C. So this is regarding the circuit diagram for the characteristic. And first of all, after drawing this circuit diagram, you have to explain the construction of this circuit diagram. You can start with base emitter junction. Construction I am talking about. Base emitter junction is connected with the battery VBB. Base emitter junction is connected with the battery VBB in the forward bias condition. To measure the current, and micro emitter is connected, and collector emitter junction is connected with battery VCC in reverse bias condition. So this is what the construction is. So take down this diagram so that we can go further. Now, so hope you have taken down the diagram. Now we have to draw the characteristic of NPN transistor with common emitter configuration. First of all, let us know what do you mean by characteristic. Characteristic means the variation of current with respect to voltage. But we are taking a common emitter configuration. Means here we are plotting the graph between voltage. It may be input voltage, it may be input current, it may be output voltage, or it may be output current. We are just plotting the graph between voltage and current by making emitter as the common. Here you can say that common emitter configuration. So first we will talk about the input characteristic. So input characteristic, we have to draw the graph between. Graph between IB and VEB. See, to understand this thing, we will understand it very in easy method. This half of the diagram I will take it as input and this half of the diagram I will take it as output. So input characteristic is graph between input current and output current. Sorry, input current and input voltage. We have to draw the graph between input current and input voltage. So how can you define it? The graph obtained by or you can say graph between, writing in a simple word, graph between input current. Input current is what? Base current. So base current and input voltage is what? Emitter base voltage. Emitter base voltage. If you draw the graph between IB and VBE, whatever the graph you obtain, that is called as input characteristic. So let us try to understand how the nature of graph will be. How will be the nature of graph? So we will take the coordinates. I am drawing the input curve here. This is the current IB in the micro ampere, and here it is the input voltage VEB in terms of volts, volt. Now, so this is against the coordinates IB and VEB. Now, so what is an input characteristic? Input characteristic is a graph obtained by plotting the base current against the base emitter voltage. Keeping, you have to keep a constant something, keeping output voltage as a constant. Keeping VCE as constant. So you have to keep this voltage as a constant. Means we have to choose here. A variable battery. So that we can change the voltage or the change in the current. Instead, variable battery you can also use a rheostat. A rheostat component can be added. So you have to keep the VCE voltage as a constant. So this is the definition of the input characteristic graph between base current and emitter base voltage, keeping output voltage, or you can say voltage of collector and emitter junction as a constant. So now if we go on increasing the input voltage, suddenly current will not increase. Because of, if you take here, this is nothing but the, I'm just drawing a small diagram. It is what? The emitter, base and collector. So I am increasing the voltage across this junction. This is what the emitter, this is what the base is, and this is what the collector is. Here, if I take, this is N and this is P. There is a junction between NP. This junction is called as base emitter junction. If you take that junction where two different kind of semiconductors join together, P and N type semiconductors join together, and there is a potential barrier, or you can say voltage barrier will be there. Until this voltage barrier is there, whatever the increase in voltage, because of that voltage barrier, if you go on increasing the input voltage up to certain voltage, there will be no current flowing across the input circuit. As we go on increasing, suppose let us understand that the voltage barrier is around 0.6 for the silicon semiconductor. If I take this NPN transistor as silicon semiconductor, it is made of silicon semiconductor, then the voltage barrier is around 0.6. if I am supplying the voltage like 0.1, 0.2 input voltage at 0.1, 0.2, 0.3, 0.4, there will be no base current because the input voltage is not sufficient to overcome this potential barrier. Until potential barrier, there will be no current. As in case of forward bias condition, until this barrier voltage, there will be no current. Once the voltage increases more than this barrier voltage, current suddenly increases. So let us, here I am making this as 0.2 and this is 0.4, this is 0.6 and this is 0.7 and so on. Now, as the voltage go on increasing from 0 to 0.2, there is no current because of the potential barrier, and still there is no current, there is no current, there is no current. As it reaches 0.6, sudden increment in the current takes place. Here you can say some current increases. So this is what the input characteristics. Input characteristic. As the voltage, input voltage go on increasing up to the potential barrier, there is no current in the input circuit, or you can say base current. There is no base current. Once the input voltage reaches the voltage barrier or potential barrier, then sudden increment in the current takes place for the further increment of input voltage. So this is what the input characteristic. So suppose let us assume that we are keeping voltage VCE constant. Let us assume that this is for 4 volt, that I am just taking an example of 4 volt output. This is VCE is equal to 4 volts. What if I increase this VCE further? What if I increase VCE by 10 volts? What will happen? Whether this 0.6 decreases, or you can say potential barrier or barrier potential decreases or increases, what will happen? Automatically, if you make the VCE is equals to 10 volts, then the curve will become like this. You can see here, up to this voltage, initially for 4 volt, up to this voltage there is no current. Now as the output voltage increases, then potential barrier is also increases. Why it is so? Because if the voltage across this one increases, here electron starts flowing from N region to P region. That increases the resistance between E and B junction, emitter and base junction. So because of this reason, here potential barrier increases. So you can remember here, as the collector emitter junction voltage go on increasing, the potential barrier go on increasing. So this is regarding the input characteristic. So I'll repeat once again. For the input characteristic, first you have to write what you mean by input characteristic. Input characteristic is a graph between, simply you can remember like, it is a graph between input current and input voltage. So input current is nothing but, here this is what the input current is, that is IB, base current, and input voltage will be voltage across the base and emitter junction. Now if you plot these two graphs, if you plot the graph against IB and VEB, keeping output voltage constant, we are keeping the output voltage constant, then whatever the graph we got, that is called as input characteristic. It is observed that whenever the input voltage go on increasing up to certain value, current is not induced. That is called as the threshold or new voltage. Up to that voltage, there will be no current induced in the input circuit. Once the input voltage increases more than the potential barrier, suddenly current increases. As it is taking place in case of forward bias. You can say that forward PN junction diode. So as we are increasing the output voltage, output voltage constant, that is what we are keeping constant. If you go on increasing, then the threshold voltage or the barrier potential also go on increasing. So this is regarding input characteristic. So I'll write some words regarding this. So hope you have noted down this one. I'm rubbing this. I'm just removing this. In simple words, I'll write input characteristic graph between input current and input voltage, keeping output voltage constant. So certain point you have to remember, as the input voltage increases, there will be no input current up to potential barrier, or I am writing barrier, voltage barrier, to voltage barrier. Once input voltage increased more than voltage barrier, sudden increment in input current takes place. And one more point we have to add. That point is, as the output voltage increase, barrier potential also increases. So these 3 points you have to add in your notes while writing the notes regarding this. So this is regarding input characteristic. Just take out the screenshot and make these 3 as your key points. First you have to write the construction. Thereafter, by these 3 points you have to prepare your notes regarding the input characteristic. Just note it down or take a screenshot so that it will be helpful for you.